All right, everyone. So part 2, let's work a couple examples of these. So hopefully you now know how to identify a vertical asymptote. It comes from the denominator, or a horizontal asymptote, which comes from analyzing the 2 degrees of the numerator and the denominator. So I'm going to do a couple of these for you. Our example, it says example number 2. I wonder where example number 1 is. Oh, there it is. Finding your vertical asymptotes. Okay, so let's find some horizontal asymptotes. Excuse me. Okay, so in order to find our horizontal asymptotes, I have to do some analyzing of top degree and bottom degree. So with number 1, or letter A, I'm going to look at the degree of the numerator. It looks like it's a degree 3, and the denominator is also a degree 3. So if I look back at my notes on the previous page, if my numerator and my denominator is the same, they are equal to each other, then it means my horizontal asymptote is lead coefficient over lead coefficient. So when I look back at these, I know I see a degree 3. This was a 3, and this was a 3. So what I need to do is look at the lead coefficient. Remember, the lead coefficient is the number that's in front of the first letter with the highest exponential degree. So this was a 6, and this one doesn't have one. So remember, it's understood to be a 1. So since the top degree is equal to the bottom degree, and you, of course, don't have to write this down. Excuse me. Then it's the lead coefficient over the lead coefficient. So y is equal to a 6 over a 1. Or you can just tell me it's y equal 6. That is the horizontal asymptote, the HA. So easy once you figure it out. Again, you can Zoom chat with me or hang out with me, and I can explain this to you in person if you would like. Well, as close to in person as we can get. Okay, let's go to the next one. So the next one, I'm looking for the degree of the top, and you see this one has no variable. So if there is no variable, then the degree is equal to 0 because there's no variable. So my top is degree 0, and my bottom, excuse me, my bottom is x to the first. So your bottom is degree 1. So since my top is smaller than the bottom, so since the top is smaller than the bottom, if that's the case, then it's always, your horizontal asymptote is always a set number at y equals 0. If the top is smaller, okay, so if the top degree is smaller than the bottom degree, then it's automatically y equals 0. You don't have to do any calculations. Now this last one is it looks like it's going to be just a bear because everything is so long. But what I'm going to do is look at the degree. So this is a degree 6, and the bottom is degree 5. So if I know that this is 6 degree over the bottom, which is a 5th degree, if that is the case, if the top is bigger than the bottom, then this is wonderful because my horizontal asymptote does not exist. And remember what we said about that? It was a DNE. Does not exist. There isn't one. Yay. All right, so let's review this real quick because we had one of each example. For our first one, the top was a 3 and the bottom was a 3. So therefore, since they're equal to each other, then it's lead coefficient over lead coefficient, 6 over 1. And the second one, the top degree is 0, the bottom degree is 1. So when the top degree is smaller than the bottom degree, then my horizontal asymptote is automatically y equals 0. I don't have to do any more evaluations. And the last one, letter C, if my top degree is bigger than the bottom degree, so top is bigger than the bottom, then your horizontal asymptote does not exist. It's as easy as that. Now, our last example that we want to look at is we want to check this by seeing if we can find them both, vertical and horizontal asymptotes. All right, the vertical one, remember, is going to be headed in the vertical direction, and the horizontal asymptote, remember, it's going to be headed in the horizontal direction. Now, we're not graphing anything yet, but we're going to. So we're going to make sure we can find our asymptotes first. They're the fences. They're the places the graph is going to get closer and closer to, but never touch. Okay, so first things first, let's go with our vertical asymptotes. To find our vertical asymptote, I am only looking at the exclusions of the denominator. So our vertical asymptote, we are looking for excluded values from the denominator. Okay, so all I need to do is find the denominator. Well, that's right here. And it's an x squared minus 4. Well, because it's x squared, I know that I'm looking for two solutions. So in order to find them, I'm going to set them equal to 0. Now, I have a choice. I can factor it, use quadratic formula, I could graph it, or I could solve it using algebra. It makes zero difference to me which one you use. I believe that factoring is always the fastest. So this is a difference of two squares. So x minus 2, x plus 2 will give me the factors of x squared minus 4. And once you find them, you set each factor equal to 0, and you solve it. So my first solution is x is equal to 2, and my second solution is x is equal to negative 2. Now, those two values are my VA, my vertical asymptote. My graph will get closer and closer to those two lines, x equals 2 and x equals negative 2, but it will never touch those two lines. When I get ready to find my horizontal asymptote, remember what I'm doing is I'm evaluating the top degree versus the bottom degree. So for me to evaluate the top degree and the bottom degree, I just need to look at their exponents. This one's a 2, and this one's a 2. Well, that's all I needed to know in order to find my horizontal asymptote. If my top degree is equal to my bottom degree, then for me to find my horizontal asymptote, it's going to be a y is equal to whatever your two lead coefficients are, 2, and this one happens to be a 1. So your horizontal asymptote is 2 over 1. So and I can simplify that if you want to. So my HA is y equals 2. Again, totally up to you to decide how you want to solve. The horizontal asymptote is just by evaluation of degrees top and bottom. Your vertical asymptote could require you to do a little bit more work. And if you would like to, you could have solved your vertical asymptote by algebra. So if I did this x squared minus 4 equals 0, I could solve this by algebra also. If I added 4, I would have x squared is equal to positive 4. And then if I took the square root of both sides, you have to remember to do the plus and minus. But this would be another method for solving. And again, it doesn't matter to me how you solve it. You just pick the best method for you, and you go from there. This is going to be your homework. So this is your Wednesday homework that is due on Monday. So this is worksheet number 1. There are 12 questions, so if you look at those, There are 12 questions on there. And the only thing I'm asking you to do, it asks you to find the horizontal asymptote and the vertical asymptote for each of these below. So, in my fashion, I'll probably do at least a couple for you. Let's just do one today. So, in order for me to find the horizontal asymptote, in order for me to find horizontal, and let me go back to my pen here. Let's go to red. Okay. In order for me to find my horizontal asymptote, remember that I'm going to let's do it in the way we've done them. So we've switched them. So we usually find vertical first and we find horizontal second. So the vertical is looking for my excluded values in the domain. So my vertical asymptote is x minus 1 equals 0. What value of x would give me a 0? And if I set it equal to 0 and solve, I find that my horizontal asymptote is my vertical asymptote is x is equal to 1. That's the excluded value from the domain. And remember that the denominator controls that. The next thing they asked me for is the horizontal asymptote. And the horizontal asymptote, I just evaluate top degree versus bottom degree. And I'll switch this one to blue. So my top degree, if there is no variable, remember that it's a 0. And my bottom degree, it looks like it has an x to the first, is a 1. So I have a 0 degree on top, and I have a 1 degree on the bottom. So since the top is smaller than the bottom, and remember, if the top is smaller than the bottom, then I know that I have something in particular, and it's always then that my horizontal asymptote is y equals 0. So when I analyze top degree versus bottom degree, since the top is smaller than the bottom, then my horizontal asymptote is always the same at y equals 0. So all I need you to do is run through this list, there's 11 left now, and tell me what your horizontal asymptote is and what your vertical asymptotes are or is if there's only one. All right, and if you have any questions, let me know. Love to set up a Zoom time with you or a Hangout if you need any extra help. All right. All right, everyone. I'll talk to you soon. Have a great day. Stay healthy and safe.